This is Dr. Balaprakasa, working as an assistant professor in Department of Computer Science and Engineering, NIT Warangal. Welcome to the sessions on basics of Python programming. So the sessions are mostly hands-on. I will not use any slides kind of things. So basically this Python is a high-level programming language. It is object-oriented. That means all the object-oriented constructs will be supported by Python. It is clean, simple and expressive language. If you want to implement some task in Python, you can implement the task with fewer lines of code compared to other programming languages. Similarly, there is no need to define data type of a variable in Python. So it will automatically infer the data type of the variable. Suppose you define something x equals to 5.5. It will automatically infer that it is a floating variable, floating point variable. So there is no need to define the data type of the variable. And then there is no need to allocate and deallocate memory. Like other programming languages, you have to allocate memory, then you have to delete the memory that was allocated for that particular data structure or variable, right? So there is no need to allocate memory also. And there is no need to compile the code and then execute the code. Python is basically interpreted language. That means you can directly execute the code. The interpreter will read statement by statement and it will directly execute the code. And the other advantage of Python includes Python has large community of users. So therefore you can easily get the help and documentation about any topic in the internet easily. And then Python supports an extensive set of libraries. Libraries for scientific computing, libraries for machine learning, libraries for data science, library for symbolic computation. Suppose you want to apply some derivatives, integration, limits. For expressions, you have some expression. You can create those expressions. There are libraries like SimPy. So people from mathematics, physics, they generally work with theoretical expressions. They wanted to apply differentiation, integration, all these things. So they can use this library called SimPy to work with differentiation and integration and expressions, symbolic expressions. Similarly, this Python has a support for inter-process communication, parallel processing, everything, GPU computing, we have support in Python. So therefore Python has a rich set of libraries for different set of tasks. Even we have some libraries for soft computing and so on. So first let me tell you how to use this Python. Suppose you wanted to, so if you are using some Linux system or Mac system, this Linux and Mac systems comes pre-installed with Python. If you are using Windows, then you have to install Python explicitly. Suppose if you want to install, if you want to download Python in Windows, then you can go to this link python.org/downloads. From here, from this link, you can download the latest version, Python 3.96, Python, you see different versions of Python are available. You can download and you can install this Python version, 2.7, 2.x version also available. So from this link, python.org/downloads, you can download a Python version. It can be 3 point something or 2 point something. You can download and you can install. But installing Python is somewhat troublesome because you have to install so many other libraries also. Therefore, the other shortcuts are also available. There are some distributions which comes pre-packaged with many other libraries. So one example of such distribution is Anaconda. So if you want to install all the libraries along with Python, then you can directly install this Anaconda. You can search for Anaconda install Windows. Anaconda install Windows, then open this first one. Here you will get the complete documentation about how to install this Anaconda in Windows. Along with each step, you can see this documentation. So this way you can install also in your system. So if you install this Anaconda, Python along with some other libraries, they will be installed, and then it will also give you some some IDEs, integrated development environments also are available. Let me open this Anaconda for you. I have already installed. If you have already installed Anaconda, then you will get this icon in start. You can open this one. You can click on this Anaconda. Then let me show you how it looks like. Yeah, it was here. You see here, Jupyter Notebook, Spider. So these are some IDEs. They are available. You can directly open Jupyter. You can write your code here. See, I'm launching Jupyter. You can launch this Jupyter and then you can write the code here. See, some codes are in my Jupyter Notebook. Okay. So if you want to open a new Jupyter Notebook, click New, Python 3. See, here you can write. So what I am going to demonstrate in these sessions, in these 4 hours of lectures, is using Google Colab. So the basic advantage of this Google Colab, I am closing all this. So if you want to install this in Windows, you can install, and you can install Anaconda. You can use this Jupyter or Spider. If you don't want to install, that is also fine. You can run this Python code in online also. So you can open this Google Collaboratory. Click on this first link. Search for this Google Collaboratory. You can open this first link. Welcome to this Google Research Collaboratory. You will get an option like this. Then you can open new notebook. You can click on this new notebook. You can click on that new notebook. So if you click that new notebook, then you will get a screen like this. Okay, let me repeat it again. Search for Google Collaboratory. Open the first link. Then you can click on the new notebook here. Here, the right side down, right side bottom. Suppose if you click, somehow skip that step, that is also fine. You go to File, open new notebook. Both ways you can open. Either you can directly click new notebook, or you can go to File and you can click on new notebook. Okay, so this way you will get this new notebook. I am closing one notebook. So you can give a name to this notebook. Let me give basics of Python programming. If you see this one, here we got two options here. One is code and the other is text. So if you put your cursor here, you see insert code cell. So using these two buttons, we can insert either a code cell or a text cell. So what is this code cell? Let me click on this code cell. You see. So code cell is something, or code cell is some space wherein you can write code and you can run this code. That's why the symbol is there, you see. If you click on this one, you write something on this cell, you can click on this button, then it will run. Okay, then what about this text? Text is like giving some headings. Suppose let me give headings like, okay, first I'm going to discuss about identifiers in Python, and then keywords, basics of some keywords, let us say, then variables and different operations that can be performed on these variables. So you can move these cells up and down also. You can click on here, you see it is moving up. So you see this is a heading. So if you open a text cell, then it can be used for headings. If you insert a code cell, then you can write some code and you can run this. Alright, so all are requested to open this Google Collaboratory and open a new notebook. So from now onwards, our discussion will go on hands-on only. So I will directly demonstrate here in this Google Collaboratory. Okay, so we'll start with these identifiers. So what is an identifier? Identifier is used to identify something, right? Let us say we have some identifier. What is our identifier? Other number is our identifier. So other number uniquely identifies a person. It can be used to distinguish one person from the other person. So similarly, identifiers in a programming language are used to distinguish between one entity to other entity. So basically, this identifier is a name. Identifier is a name given to a variable or a function or a class, something. So it is a name given to some entity. It can be variable, or it can be class, or it can be function also. So there are some rules to define an identifier. What are the rules? Rules are identifier name in Python can include numbers, can include alphabets, can include underscore. These are the only things that can be included. What are the things? We can have alphabets, we can have numbers, we can have underscore character. Okay, so we can have this one, but any combination of these alphabets, numbers and underscore, is it fine? No. An identifier should not start with a number. Identifier should not start with a number. You can start with a alphabet. It can be capital alphabet or small alphabet. It is okay. You can start with an underscore, but never start an identifier with a number. If you start an identifier with a number, then it will throw an error. Similarly, some punctuation characters like @ dollar, percentile, these are also not allowed in identifier name. So only these are allowed: alphabets, numbers, underscores, and never start a identifier name with a number. It means digit. Rather than writing number, let me write digits. It can have alphabets, digits, underscore, but never start a identifier name with a digit. So we'll see now. Okay, so this is about identifiers. Then what about these keywords? Like all other programming languages, we have some keywords in Python. What are these keywords? Let us say you want to write an if loop. How do you start an if loop in other programming languages? You write like if, some condition, some body, like all these things you write. So where if is a keyword, right? So keywords should not be used as a variable name. This is the other constraint, other condition in all programming languages. This is true. Keyword should never be used as a variable or identifier. Okay, so that's all about this identifiers and keywords. Let me directly go into coding now. So enough with the discussion. Let me go here. You see, this is a heading. So this is a text cell. Now this is a code cell. Let me start with the coding. So let me start with variables in Python. So at the beginning, I have emphasized that the advantage of Python is that there is no need to define data type of a variable. You can directly assign a value to a variable. It will automatically infer the data type, right? That's what I said. So let us see now with demonstration. So suppose you want to define some variable. Let me directly write x equals to 5. So if you want to run this one, click here. Okay, click this button, or you can press Ctrl Enter also. You see it was rotating, that means it was running. X equals to 5. Yeah, it is success. Tick mark came means it is success. Suppose if you want to see the value inside this one, you can use either print or you can directly write x here in this case. In program, you have to use print. Let me use print only. Let me run it again. You see, the value inside this is 5. Now, let me define one more variable, y. Let me give a value 5.567. You see, this is a floating point variable. That's all. No need to define the data type. Now, what I wanted to show you is, let us see the data type of x. I said it will automatically infer the data type of the variable, right? There is a inbuilt, there is a function called type. If you give type, if you give a variable as an input to this function type, then it will return the type of that variable. Let me run this one. You see type of x. What is type of x? It is an integer variable. Similarly, you give type of y. see, it is a floating point variable. Similarly, you can define strings also. Okay, characters. Let me define some other variable z. Let me give some string here. Okay, what I should give? Ramanujan College. Ramanujan. Now let me see that type of this variable, this particular variable, type of z. Can you see? So it will basically it will automatically infer the data type of that particular variable. You simply write variable name, assign some value. You see, you know, right? If you are new to programming, this is a variable name. Equals to means you are assigning some value to this variable y. That's all. So I hope most of you are at least familiar with at least one of the language, C programming at least. So this is about variables. Even if you are not familiar also, it is okay. Variable, basically variable is used to store some value. Variable is used to store some value, and the name variable was given because you can change the value also. Now I have defined y equals to 5.567, right? Let me print the value. Let me print y. The value is 5.567. Now you can change the value. That's why the name variable was used. Variable means its value varies. So y equals to, let me change the value to 7.8. You see, now let us print the value. Print y. It contains 7.8. That's why the name variable was given. Although it looks funny since I am explaining why the name variable was given, but if you are new to programming language, then it makes sense why the name variable was given. Okay, all right. So you see, every time I am creating this code cell and then I am writing my code and I am running using this by clicking on this button, or I am directly clicking Control Enter. You also do the same thing. Click on this code cell, then enter your code, then run it using this button. Now this is about variables. So you can define variables, no need to define data type. You can give integer value or floating point value or string. You can do anything. Now we have some variables. Now the moment we have some variables, what is the next question that comes to our mind? Okay, we have some two variables x and y. Let us say what we can do with these variables, right? Let us say in this case I have defined x and I defined y. Now what I can do with these variables? So like all other programming languages, Python supports some operations that can be performed on these variables. Let us say Python supports Arithmetic Operations, it supports Relational Operations, it supports Bitwise Operations, and it supports some inbuilt functions. Also we'll see these things. So first let us start with these Arithmetic Operations. So let me click on this text cell. So let me discuss operators. Operators means what? They operate on variables. So far we have defined some variables x and y. Let us try to operate with those variables. So let me define one more variable x. I already defined x, right? Let me again define x equals to 5, x1 equals to 7. Okay, let me give more value here. X equals to 15 by x1 equals to 7. Okay, now arithmetic operations means what? Addition, subtraction, division, multiplication. All these operations are performed are supported by Python. So let me write in next cell. Let me run it first. You see, I have already ran the cell. Now let me open a new cell. Now let me perform some arithmetic operations. X plus x1. That's all. This is addition. Similarly, you can use minus for subtraction, star for multiplication, slash for division, right? You can use all these things. X by x1, x by x1. X by x1 is 2.1428 and so on. So similarly, here you see what you got. You got a quotient. When you gave x by x1, we are always getting quotient. Suppose if you want to find the remainder, then it supports an operation mod operation. X mod x1. X mod x1 is 1. Because the remainder is, you see, when you divide 15 by 7, the remainder is 1, right? So this is remainder. Here we are getting quotient, here we are getting remainder. Now if you want to find both remainder and quotient, there is an inbuilt function. We will see later when I am discussing functions. Functions means after operations, let me discuss. Or okay, let me discuss here. So there is an inbuilt function called div mod. So what it will do, it will perform division and modulo operation. You see here, this is division operation, this is modulo operation. So this div mod combines both the operations. So let me give div mod of 15, 7. So what it will give you? It will give you 2 and 1. 2 is the quotient, 1 is the remainder. See, it combines both division and modulo operation, right? So similarly, you can implement something called x power y. Let us say x power x1. How to do x power x1? So there is a function, there is a operator, this double star. Double star indicates power, x power x1. Now let me run it. X power x1 is this one, you see. X power x1 means what? 15 power 7. It was giving this value, 15 power 7. Okay. Similarly, there is something called other operations are also there. So these are arithmetic operations: addition, subtraction, division, multiplication, modulo, and then combining division and modulo, power operation, and so on. So similarly, Python supports relational operators also. Relational operator means what? You can compare between two variables. Let us say x, whether it is equals to x1. You can check this one. This is checking. This is not an assignment operator. You see, double equals to means you are comparing whether x is equivalent to x1 or not. Let me run. You see, false. Obviously, because x, what is the value of x? X is 15, x1 is 7. So they are not equal. Similarly, if you want to check whether x is greater than x1, you can check. True, because 15 is greater than 7. Similarly, x is less than 7, x is greater than or equals to 7, less than or equals to 7. Whether x is, similarly you can check whether they are equality, we checked. Not equality also we can check. This is the not equality operation. You can check whether they are equal or not equal. Yeah, they are not equal. So that's why it is giving true. If they are equal, and if you give this operator, not equals to operator, then it will return false. This is self-explanatory anyhow. So these are the relational operators that is supported by Python. So similarly, Python supports bitwise operators also. Bitwise operator means what? They operate on bits. So let us say you want to perform bitwise AND. Let us say, let me take simple things. 2. Let us say 3. What is 3? The binary in bits. Binary value of 3 is what? 0 0 0 1 1 0 1 1 0 1 2 3 1 1. It is 1 1. Similarly, 2 means what? 2 means 1 0, right? This is the binary equivalent of 2. This is the first one is binary equivalent of 3. Second one is binary equivalent of 2. So let me give directly 3 and 2. So what is 3? 1 1. What is 2? 1 0. If you perform AND operation, what will be the result? It is 1 0. So now let me run it. It is giving 2. This is self-explanatory, right? Just now I have written 3 means 1 1 and 2 means 1 0. If you perform bitwise AND operation, see, let me run here otherwise. Let me show like this. You see, 1 1 1 0. So the result will be, it is 1 0, right? So here let me write comment. So Python supports comments also. You can write here like this. So it will not be executed now. Otherwise it will be part of code. Okay, now let me run. Okay, unexpected indent. Oh, indentation problem. Okay, leave it. Indentation I have not discussed, right? Okay, no issue. But the result is 2. So it is a bitwise AND operator. Similarly, Python supports bitwise OR operator. OR operation is simple. This one, this bar, bitwise OR operation. It supports XOR operation. Bitwise and XOR. XOR is this caret symbol. Bitwise XOR. You can cross check the results whether it is giving correct values or not. It is bitwise XOR operation. If you want to complement a number, let us say 3, you want to complement. you can use this complement one, this is the complement operation. You can give any value, it will complement and it will give you, right? This is the value, you can cross check the value. Similarly, you can perform left shift operation and right shift operation. This is the left shift operation, this is the right shift operation. You can perform with these numbers, right? Let me give x equals to 5 and then x left shift 2 times. What will be the result? Result will be 20, because if you perform one left shift, the number will be doubled. Since we are performing 2 left shifts, 5 becomes 10, 10 becomes 20. Alright, so Python supports arithmetic operations, bitwise operations, relational operations, right? Now we'll see some of the inbuilt functions that were supported by Python, which will be useful. So some of the built-in functions, like suppose you want to convert one number system to other number system, right? So there are inbuilt functions in Python. Suppose you want to convert some number into hexadecimal. Let me give 15. I want to convert into hexadecimal. You simply write this code, hex of 15. It will convert into hexadecimal. Now if you convert into octal, oct of 15, you give. It is, you see here, x stands for, this is a octadecimal number. O stands for, it is a octal number. That's right. That's all. Okay. So similar way, you can convert from one number system to other number system. If you want to explore about all other inbuilt functions, you can explore, because I will cover other things. So similarly, if you want to find a Ascii value of a character, then there is a function called ORD. Then you give Ascii, let us say capital A. You can find Ascii value of a character. You see, with this function ORD of A, it is 65. Similarly, if you want to find this is Ascii value, if you give Ascii value and if you want to find the symbol corresponding to an Ascii value, then there is a function called CHR. You see, CHR, let me give 98, what it will give. The Ascii value corresponding to 98 is small b. So the other advantage of this Google Colab is that there is no need to install libraries. All the libraries comes pre-packaged. There is no need to explicitly install libraries. But if you use your Python in your local machine, then you have to take care of these modules. You have to install these modules on your own, right? You have to take care of the errors and all these things. But whereas in this Google Collaboratory, there is no need to install these modules, no need to worry about modules. All the modules were pre-packaged, pre-installed, everything. Right, it runs on some cloud, so there is no issue. All these issues will not arise. So this is very handy environment. So if you see here, we are running this code online, right? It will run somewhere and the results will be displayed here. Okay. So we'll see some other inbuilt functions which are useful. So other important, like, okay, div mod we discussed, right? Division, we can combine division and modulo. That is also one inbuilt function. Similarly, there is a inbuilt function called compare. Okay, so let me define two variables, x equals to 10, y equals to 8. Now let me compare x comma y. Compare, I think it is depreciated. Okay, no issue. It is depreciated, I think. X comma y. Okay, it was supported in earlier Python versions, but it was not supported. No need to worry. Okay, now we'll see other functions. Like there is a function which is very much useful in Python called range. So what this range will do? This range function, if you see, you can see the out. So this is what I wanted to tell. In Google Colab, if you write some function and if you leave, then it will give description about that function. You can read the description of that function. You see here. Range. If you give only stop, you can give start, stop, step, all these things. So let me let me describe about this function. So this range, what it will do is, this function outputs integers in a specified range. So what do you mean by outputting integers in a specified range? Let me give a number 10 and let me run it and see what it is giving. So it is giving numbers from 0 to 10. So let me first print. So printing whether it is working. No, it is not working. So let me, at this point, don't worry about the function I'm using. Okay, just now I used this one. I will describe this function later on. This is just for printing these values that are there inside this function. So range of 10, what it will give is, it will give a list of numbers from 0 to 9. So if you give 11, it will give up to 10. So range of numbers starting from 0 but not including 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, up to 9. So if you give a single integer, then from 0 starts with 0 till that number but not including that number, it will generate integers. Now let me change this function a little bit. Let me give one more. Let me give 2 here. Then what will happen? If you give starting 1, then it will numbers starting from 2, it will go up to 9 but not including 10, right? Similarly, there is the other version of this range. What is that one? If you call 2, 10 and something called step length, you see here. So starting with 2, the next number will be 2 plus 2. This is called step length. 2 plus 2 is 4. The next number will be 4 plus 2, 6. The next number will be 6 plus 2, 8. The next number will be 8 plus 2, 10. So it will not be generated, but not including 10. That's what we are telling from beginning. So from 2 with step length 2. So it will generate integers starting from 2 with step length 2. This is the idea of range function. This will be very useful in for loop, this range function. So okay, next. So this is about range function. So similarly, if you want to read input from user, so Python supports functions for reading input from users also. So there is a function, inbuilt function called input. So inside this function input, you can write some set text, whatever you want. Enter input data. You see, it was asking for the user to enter the input. Now what I do is, I will take the input and I will store in some variable. Let us say A. Let me run it again. Cell is already running. Okay, I have to give some value first. 2. So this is the earlier version before assigning to variable. You see, enter input data. I have entered, so it was storing here. So let me give A equals to. Let me run it again. Let me give 2. Let me give this time 40. Now 40. I have entered 40. Now we'll see what exactly is there inside A. You can see 40 was there inside A. Alright, so this is the way to take input from user. So far what we have seen, we have discussed the advantages of Python. Then we have seen how to install Python in Windows. So I have not described the entire procedure, but I have given the links, right? How to install. So rather than installing Python and all the modules manually, it is better to use some distributions like Anaconda, which comes prepackaged with all the modules, right? So the better option than Anaconda is using this Google Colab, and I have described how to open this Google Colab. Then we started with identifiers, keywords. Then we discussed the variables, the advantage of defining variables in Python. Then we have seen some of the operations that can be applied on these variables. Then we have seen some of the inbuilt functions which are very useful. Later, after some time, we'll use this range function and so on. And we have also seen how to take data as input from the user.